All right. Hello, everyone, and welcome to the San Anselmo Library's virtual program today, Climate Smart Gardening, Part 1, Impact and Mitigation with Marin Master Gardener, Kathy Hunting. I'm Sariana, the Adult Services Librarian at the San Anselmo Library. And before we begin, I'd like to thank the Friends of the Library and the Library Parcel Tax for sponsoring this program and all library programs. Our speaker today is Kathy Hunting. She's been a Marin Master Gardener since 2014 and is an environmental health scientist by training. She lives on a sunny acre in Point Reyes Station where her garden is full of tasty vegetables and fruits. She also attempts to grow ornamentals that the deer will not find as tasty. We also have Marin Master Gardener Barbara Robertson joining us today. She became a Master Gardener in 2015 and has turned her skills as a journalist toward writing some of the Master Gardener columns in the Marin IJ. She has a shady garden in Tam Valley where she grows strawberries, potatoes, lettuce, and ferns. Everyone will remain muted until the end of the presentation. If you have a question for Kathy, please type it into the chat box. Barbara will be monitoring the chat and will answer the questions directly in the chat or alert Kathy to any questions she should answer live. Technology can be very fickle, and I want to thank you all in advance for your patience and understanding during this program. We are recording this program today, so if you miss anything, I will send the recording out to everyone who registered later today. Please join me in welcoming both Kathy and Barbara. Woo, yay! Everyone's muted, but let's all cheer quietly. Woo, yay!
Thank you, Sariana. I'm sharing my screen so that we can get going. And thanks to the San Anselmo Library for hosting us. Master Gardeners are always happy to get the word out on best practices in horticulture to our community. So thank you all for being here. I saw a few familiar faces as you all logged on. Just for some of you who don't know what Master Gardeners do, we're trained volunteers, and our mission is to share our knowledge and skills with the public about home horticulture, pest management, and best practices in sustainable landscaping. We have quite a number of community-oriented programs, including our help desk, our public website, which has just been gone through a major upgrade. If you have not visited it, I encourage you to use that as your primary resource for great information about home gardening. And I'll have some links for you at the end where you can find our website, etc., if you don't know. So the talk today is in two parts. I'm going to spend the first 15 minutes or so talking about the impacts of climate change and as they pertain to gardening practices. And then after that, we'll transition into ways that ways that home gardeners can be involved in climate change solutions in the garden. So it's a little overwhelming, the topic of climate change. It can be just the vast amount of scientific data can be overwhelming, and it can be emotionally overwhelming to consider all the many pretty grim impacts of climate change that we know have already begun and that will get considerably worse in the coming few decades. We hope to focus this talk in on just a few aspects of climate change in order to have this topic feel more approachable for you and to give you a sense of the climate change factors that are most relevant to home gardeners. And those are four, and they're summarized here on the slide. I'm going to be talking about temperature increases, about flooding and drought, about ecosystem changes, that result from climate change, that are resulting from climate change already, and what climate change can do to the soil. So let's start with temperatures. This is one of the most carefully modeled aspects of climate change science. And although it's carefully modeled, there are a number of assumptions that go into all the models that climate change scientists do. And so these figures and predictions that are presented here on this slide represent the best estimate that climate scientists have for what's going to happen over the next few decades. We know that our average annual high temperatures have already increased about 1.7 degrees Fahrenheit from 1950 until the mid 2000s. We're likely to see another 3-degree increase Fahrenheit in temperatures by the middle of this century, that is by 2150. And that is assuming that the world collectively gets together and implements policies that are more stringent at controlling greenhouse gases. If the world does not adopt stringent policies, we could be seeing more than 3 degrees Fahrenheit of additional increase by the middle of this century. And so what is the relevance of that for the garden? Well, it's pretty, I think, evident to see that when the temperature rises, plants are going to need more water, for example, because they're going to dry out faster. But some of the maybe less obvious impacts of rising temperatures is that plants may not get the rest period that they need in the dormant season, in which for us, for most plants, is usually the winter. And so they need that period of rest in the winter when they go dormant. And if temperatures continue to be warmer through the winter, they may not be as vigorous when plants come ready to approach the growing season in the spring. Those of you who are fruit and nut tree growers may have impacts in your orchard, because most fruit trees need some chilling in the winter, need some periods of cold in the winter to produce optimally during the growing season. We also are seeing significantly less fog in our coastal climate. We're really lucky here in Marin to be living in a place where our climate is moderated by the ocean and the bay, that are both, really surrounding us on two sides of the county. But we're getting less coastal fog, and coastal fog is a significant contributor to plant moisture during the dry season. So that's another impact. And just something that I've been seeing this early spring in my own garden is I have a few plants that are a little bit frost tender. And for example, calla lilies send out their growth in January, when it got so warm in December and January, and then frost came and the leaves and blossoms got frosted. And that's true for many frost tender plants, that we're going to see them encouraged to send out their growth, and then they get frosted because the spring temperatures are really, late winter and early spring temperatures are quite variable. We also need to think about what's happening to our climate zones. And one of the climate zones that we rely on is the US plant hardiness zones, which are the zones that tell us how much cold a plant can take in the winter before it succumbs to frost. And our plant hardiness zones across the US are moving north. Here where we are on the coast, they tend to move inland. And so what that means is that what used to be the climate that we saw, say, in Petaluma, is becoming the climate that we're seeing in some parts of northern Marin as climate zones as that warm zone moves out towards the coasts from the warmer inland valleys. So those are just some of the impacts of rising temperatures. Another impact of climate change is that we're seeing extreme rainfall patterns. One of the really hallmark characteristics of climate change is that our weather and climate systems are getting much more erratic and unstable. And one of the manifestations of that is extreme rainfall and drought. So even though the climate models say that our average rainfall in the San Francisco Bay Area isn't expected to change substantially, we're going to be getting more very wet years and more very dry years. So more variability year to year. And our largest winter storms that we call atmospheric rivers, because they really are like a very large river of moisture in the sky, are going to become more damaging and more intense. And so what happens when we've got extreme rainfall? Well, you all know that you see runoff, and we see flooding when waterways rise. So when that happens in the garden, we can see waterlogged plant roots, which is a key cause of plants not living, of plants dying. When we combine that, for those of you near the coasts, with sea level rise, that worsens the flooding even more. And just as an example, we had really wet years in 2017 and 2019. Probably most of you remember the flooding that we had across the county in those years. Then on the opposite side, we have drought, and the severe 5-year drought from 2012 to 2016 broke all the record books in California. And we are now in the second dry winter, and most of California is in a state of drought. The drought map isn't as severe as the drought map shown in the upper right-hand part of this slide, which was from 2016 in January, but we could be heading into another multi-year drought because our rainfall has been so low. When you combine less rainfall in a drought year with higher temperatures from climate change, we get soil that dries out faster, therefore plants dry out faster, therefore plants are stressed in the garden and need more water to survive, or we need to come up with different gardening strategies and plants that take less water. We also have the extremely serious problem of wildfires that are exacerbated during climate change, in the context of climate change, because we have a much longer dry season because of higher temperatures, where plants have lost their moisture and become fuel for fires. So drought is a really significant problem for gardeners. The third impact that I just want to summarize briefly of climate change that's relevant for gardeners is that we are seeing very significant changes in our ecosystems. And some of the manifestations of that is that our vegetation is becoming out of sync with our climate. And so some of our evergreen forests may not thrive as well. And vegetation that's more adapted to heat may want to move in. We may have invasives that are able to more quickly adapt to changing climate and take the place of our native plant communities. Pollinators, the insects and birds that pollinate our gardens, might be out of sync from when plants are blooming. And so these changes mean that gardeners can be part of the solution to help foster biodiversity in our gardens and make habitats that are friendly for pollinators. Barbara, did I see your hand? Do we have a question?
No, I didn't mean to raise my hand, but I'm about to put some links to climate change predictors for people to use if they want to see how the zones might change for their own house, actually. So I'm going to put that in the chat for anyone who wants to take a look.
Good. Well, I'm glad I thought I saw your hand. And then the kind of final part of the equation for ecosystem, besides plants and insects, is that many of us like seeing wildlife, if not directly in our gardens, then around our homes. And wildlife ecology is certainly changing along with the rest of our ecology. The fourth impact of climate change is on soil. And some of you may know that beneath our feet, when we're standing on the ground, is a living, intensely living community of organisms. It's not just dirt. Soil is a whole ecosystem of living organisms, and global warming can impact those living organisms that make our soil healthy. They can alter microbial communities. Sometimes an increase in activity of microbial communities can be a good thing, but other times they can damage the mycorrhizal fungus and other kinds of microbial ecosystems that are in the soil. When soil changes and dries out, it can accelerate the loss of carbon that's stored in the soil, and can also, and that in turn makes the soil less able to grow plants. And it's plants actually that are the key to soil being able to hold the carbon. So it becomes circular when soil dries out and loses plants. It loses carbon back to the atmosphere, and plants also die, and that even accelerates the loss of carbon. So soil science in the face of climate change is extremely complex. There's a lot of feedback mechanisms and a lot of different ways that altered moisture and temperature can impact the soil. So I'm going to stop there with soil and just kind of reflect on the four factors that we're going to then talk about, kind of how we can come up with some solutions in the garden. So our impacts are from rising temperatures, from flooding and drought, from ecosystem changes, and from soil alterations. Okay, so the doom and gloom, we're going to kind of try to say goodbye to the gloom and doom and think more positively, because this part of the talk is focusing on climate change mitigation. And what do we mean by mitigation? In the context of climate change, what we mean is actually reducing the amount of carbon dioxide, which is CO2, and other greenhouse gases like methane in the atmosphere. And so mitigation measures can help bring down CO2 in the atmosphere and help hopefully contribute, every gardener doing just a little bit to contribute to the solutions to climate change. And so there's 5 practices that we're going to focus on here. And one is carbon farming. I'm going to tell you what that means. Another's focusing on water. Others focusing on edibles gardening. And then plant care approaches that are carbon conscious. And then plant and food waste, which is a huge problem. Another thing that I wanted to say at the beginning of this talk, I keep saying we, even though I'm the only one talking here, because Barbara Robertson was the primary author of this presentation. She and I developed this this 2-part presentation together, but she did most of the research and wrote the talk. So when I say we, I mean me and Barbara, although it's coming out of my mouth. So I want to start here by talking about carbon in the soil and in plants. And when we say farm carbon, what we mean is taking carbon out of the atmosphere, and carbon dioxide, the same thing here, taking it out of the atmosphere and having it be stored in the soil and in plants, especially the larger plants like trees and shrubs. So soil stores carbon and trees store carbon. Before I get into details, I want to take you briefly and remind you what the carbon cycle is. Probably most of us learned about the carbon cycle probably somewhere around 9th grade or so, I guess. I don't remember when I learned about it, but that seems about right. And the key thing to remember about this carbon cycle is that plants are really kind of magical. Through the process of photosynthesis, plants take carbon dioxide out of the air and they convert it along when they have sunlight, they convert it to plant tissue. And that is just, I don't know, to me, it's magic. And then what else happens in the carbon cycle? Well, plants break down and they release their stored carbon into the soil if they are allowed to turn into compost on the soil. And we also have animals who are putting their droppings into the soil. That decomposes, that helps the soil store more carbon. And the soil also releases some carbon back into the air. And that starts the cycle over again. So that's the basics of the carbon cycle. So what do we mean when we say farming carbon in the soil? So soil does a lot of things. It holds carbon in the form of organic matter. It stores water, and soil also reduces greenhouse gas emissions through that carbon storage. The more plants that are growing in the soil, the more carbon the soil can hold. And so it's a positive feedback loop. It's really circular. So the healthier we can make the soil by increasing the organic matter in the soil, the more carbon the soil can hold and the more productive it can then be. So that is a positive kind of circular feedback loop. And so some of the things we can do to help the soil store more carbon and lock up the carbon is to reduce turning over our soil or reduce tillage. In agriculture, the low till methods are a major trend in the last, I don't know, probably the last decade or so, I would say. And in home gardens, the same thing is true. So the less you disturb the soil, the more carbon it can hold. You may need to rototill or something like that the first time you dig a garden bed, or you may need to dig down and turn the soil from deep down. But once you have a garden bed established, practices like just leaving mulch and compost on top of the soil, letting them work their way in and improve the quality of the soil. Just digging small holes to plant your plant rather than turning over necessarily a whole bed can help the soil retain carbon. Bare soil is vulnerable to erosion. And when soil erodes, its structure breaks down, it becomes less healthy for plants, and it loses carbon. And so we like to encourage covering soil with plants. If you're an edibles gardener, that's why we talk about cover crops in the off season if there's a garden bed you're not using. At the very least, we encourage you to cover soil with mulch if it's not all planted, and preferably a mulch made of organic material that can break down and improve the quality of the soil. But compost is our best friend, and applications of compost to the soil will help the soil be more productive and more able to store carbon. I would say the exception there is that some native plants don't like rich soil. And so if you're interested in increasing the number of native plants in your garden, read the descriptions of the kind of soil that they like. And if it says this plant this plant likes lean soil, or this plant, doesn't like really rich soil, that's a time when you don't necessarily need to enrich your soil with compost. But in general, plants like soil that has a good amount of organic matter, and they'll be healthier and more resilient to the impact of climate change. Barbara, are we good so far on questions?
Yes, we are. We're doing fine.
Okay, good.
I wanted to, though, mention, if you're going to mulch, pull the mulch away from trees. Mulch shouldn't be right up next to a tree trunk. And if it's wood mulch, pull it away from structures to be fire smart.
Great point, thank you. So another way to farm carbon is by planting trees and shrubs. So I mentioned earlier that all plants store carbon. The bigger the plants are, the more carbon they store. And that's why we focus in kind of the climate mitigation arena on planting trees and woody shrubs, because they are more effective at storing carbon and removing it from the atmosphere compared to smaller plants. But all plants are good. All plants store carbon. If the trees are fast growing, they're going to accumulate carbon faster. And that's why when back before COVID, when you bought an airline ticket the last time, maybe you saw an option to offset the emissions from your plane flight by supporting a project somewhere in the world that planted trees. That's why climate change mitigation folks are emphasizing tree planting, is because of its impact on carbon. The other thing trees and shrubs provide, large shrubs, is that they can shade our homes and provide windbreaks. And that's an important aspect to helping adapt our home environments to increasing temperatures, is to plant a tree where it's going to cast, once it grows, where it's going to cast shade in the winter over a home or over a patio. We don't want to have them too close to the house for fire smart landscaping practices, but far enough away, 10 feet away is the general guideline. You should never have a tree overhanging within 10 feet of the house. But do think about how you can get some afternoon shade or a windbreak from a tree. Caring for trees and woody shrubs and all plants is really important, especially for fire resiliency in the landscape. And we're focusing as master gardeners more and more on the type of maintenance that home gardeners need to practice to keep their landscapes less flammable. So pruning out dead branches, making sure that the interior of a tree or shrub isn't filled with dead material that's going to ignite. And for the climate smart part of it, we encourage hand pruning rather than firing up a chainsaw that runs on fossil fuel or some other, electric or gas powered tool. So caring for trees is really important. For fire smart, we also want to limb up. And by that we mean taking off the low branches on a tree and making sure that there's vertical clearance between that tree and what's planted underneath of it. So maintenance is super important. And before you select a tree, you should always think about what it's going to take, how much maintenance it's going to take care of that trees. The other thing to be really cognizant of is if you're in the market for a new tree or a shrub, large shrub in your landscape, is that this is an investment for decades. That tree you plant now or large shrub, hopefully it's going to be alive 30 years from now. And in 30 years from now, 20 years from now, we're going to have a slightly different climate than we have today. And so think about what the climate is going to be like and choose a shrub that grows well in a place that's 2 or 3 degrees warmer than here, which is what our climate is going to be like in another 20 years or so. So plant a tree that's well adapted for the conditions that we're going to be seeing into the future. And here for our coastal climate, that tends to be somewhere a little bit inland of us, maybe somewhere south of us, maybe somewhere a little inland of us. And the predictors that, the climate predictors that Barbara put up in the chat a little bit ago will help you understand the impact in your local area. It's a zip code, they're zip code searchable, so pretty cool. Okay, the second climate smart gardening strategy for mitigation is to reduce our water usage in the garden. And the reason that that is a climate mitigation strategy is that it takes a heck of a lot of energy to produce clean water. Water has a very significant carbon footprint. And in California, since we're mostly an electric fuel economy, that means it's taking a lot of electricity to produce our energy. Some of that electricity is coming from fossil fuels. So anytime you save water, you are decreasing the amount of greenhouse gases emitted into the atmosphere that it took to produce that water. So another thing we need to be aware of, as we can't just kind of say, okay, so I'm not going to water my garden, because we need to keep our plants alive. We need to keep them healthy so they'll be resilient to climate change, to new pests, to fire. So we need to hydrate them wisely. That means grouping plants into what we call hydrozones. That is putting plants with similar water needs together in the garden so that the irrigation that you use is appropriate for all the plants that are next to each other in the garden. Drip irrigation is the most efficient way to get water to the root zone of plants. It means you're just watering where the plants need it, and you're not watering all the soil that may not have plants on it. Drip irrigation is also, because it's often under mulch, it's less able to evaporate than, say, if you water by hand with a hose, and some of that water is going to evaporate. Putting mulch on top of the soil, you know from doing that, those of you who have, how much difference it makes in the soil staying moist if you have a mulch layer on top and you need to water much less often. And when you do water deeply, and deeply can mean different things depending on what kind of plants you're watering. And so if it's annuals, they have pretty shallow roots. And many vegetables like lettuce also have shallow roots. But if it's perennials, trees, their root zone may go down much farther, and you can learn about that specifically for specific plants. But think about when you're watering your more deep-rooted plants, you want to get water down to about a foot in the soil where the little rootlets are that take up the water. So water less often, but water more deeply so that the plants are then incentivized to develop deep roots so that they can utilize that water that's stored deeply in the soil. Another approach for reducing water usage is to choose plants that are summer dry, adapted to summer dry and winter wet conditions. Those would be our Mediterranean plants that come from the Mediterranean basin, South Africa, Australia, and the western coast of South America, Chile. And of course, California natives are also Mediterranean plants. And Mediterranean plants, at least the ones that are appropriate for our region, tend to thrive in summer dry and winter wet weather. And so that's perfect because we have a very long summer dry season. And so it's important to be able to not need to water too frequently during the dry season. And then another approach for reducing water usage is by capturing that water in your landscape, either by rainwater harvesting in barrels or storage tanks, or by creating landscape features like swales or rain gardens to capture the water in the landscape and direct it to where it can be used to support plant life. Another thing to consider is if you're putting in hardscape, make sure that that patio is going to be porous. I'm actually getting ready to do some landscaping in my front yard. And when I was talking with a contractor, I said, and he proposed to lay cement under flagstone. And I said, no, I want it set in sand so that the patio will be porous. I don't want that water running off I want it soaking back in and replenishing the groundwater table. So thinking about porous hardscape is important too. Okay, happens to be one of my personal favorites in terms of climate change mitigation because I am a passionate edibles gardener. But growing your own food is actually part of the solution to climate change. And it works in a couple of ways. Number one is it's kind of the emotional impact of growing your own food. When you grow your own food, you just naturally want to eat a diet that's heavier on vegetables and fruit. And that is a climate-friendly diet. So master gardeners are not proselytizing about being vegetarian or anything, but it's just a natural thing that when you grow food in your own garden or a community garden, you're going to be more enthusiastic about packing your diet with fruits and vegetables. But the scientific basis for it is that locally grown food, whether that's food you grow in your own garden or food that you get at a farm stand or farmer's market that's grown by farmers near you, is eliminating all the fossil fuel that goes into the commercial food transport network. So when we grow our own food or we buy food that's produced quite locally, we're eliminating a ton of fossil fuels from transportation, distribution, and storage of food coming, vast differences, from thousands of miles away. So we're greatly decreasing the carbon footprint of our food supply if we get it locally. If we grow it organically, it also requires less energy inputs because synthetic pesticides and synthetic fertilizers are created from fossil fuels. So if we use organic practices in growing our own food, that is going to be more energy efficient than food that's grown using regular, organic, conventional agricultural practices. So, plug for growing your own food. Talk for a minute about being carbon conscious when we're in the garden caring for our plants. So I mentioned before that hand tools are preferable to tools that take gas. Electric tools are better than tools that need gas to run on as well, especially if the electricity is produced from renewable energy sources. As I mentioned before, we want to avoid chemical pesticides whenever we can or reduce their use. And then compost and other organic kinds of fertilizers are not only more energy efficient, energy reducing than chemical fertilizers, but they're also healthier for the soil and therefore for the plants. Because when we dose the plants with synthetic fertilizers, it gives the plants a big immediate charge of nutrients, which is not always the best and healthiest way for a plant to grow. But when we give the soil a more modest additive like compost that has a little bit lower intensity of its nutrient composition, it feeds the soil, makes the soil more healthy and more productive, and that translates into better plant nutrition and a healthier garden. If you're growing edibles, as I mentioned, you can plant a cover crop in the off season if you have an off season. Maybe you grow kale and onions and other winter veggies. But usually most people have a few beds or a little bit of garden space that's not used in the winter. And it's great to grow cover crops then. And some cover crops, legumes, and that's plants like bell beans or fava beans, vetch, clover, add nitrogen to the soil. They have these little nodules on their roots that store nitrogen and make the nitrogen available to the fungal network in the soil and therefore to the plants. And so not only does a cover crop add nitrogen to the soil that the plants are going to need in the next growing season, but it keeps the soil covered during the off season so that if we get an atmospheric river rain, it doesn't erode the soil. It protects the soil from erosion. Another thing we can do as edibles gardeners is rotate our food crops, and that's an important strategy to keep pests at bay. And then the final thing I wanted to say about that, you may have heard conflicting things about peat moss. Peat moss is pretty widely used in potting soil and in home and commercial agriculture. But peat moss, peat beds, peat bogs store an incredible amount of carbon. And when peat bogs are mined, that carbon is released into the atmosphere. And so the science lately has really looked into that and said, if we can find other kinds of soil amendments rather than peat moss, it would be better to avoid like potting mixes with peat moss in them. Okay, one more, and that is plant and food waste. Food waste accounts for about 22% of what goes into the landfill. That's on average. It may differ from place to place. But here is the bad side of that for climate change. When organic material like food goes into a landfill and gets covered and then breaks down in that covered environment without oxygen, it produces methane as the breakdown product of this rotting food. And methane is a super potent greenhouse gas. And that methane is then emitted from the landfill into the air. And so by any means necessary, we need to keep our garden waste, our plant waste, and our food waste out of the landfill. It can go in your green bin, and the haulers will take it to a facility that produces compost under aerobic conditions, that is with oxygen. Or ideally, if you have room on your property for a compost pile, you can compost your own. And there's lots of information on the Master Gardener website about how to compost your own plant waste and food waste. And then it's black gold for your garden. The other ways that you can help manage your plant waste, if you have trees that drop their leaves in the fall, you can leave them in place, or you can run a mower over them and chop them up a little bit and leave them in place to decompose. Or you can rake them into a compost pile. That works too. And if you do have a lawn, leaving grass clippings in place on the lawn helps give more nutrients back to your lawn, and they'll degrade there just fine. So these are the 5 practices we just talked about that gardeners can employ to help contribute to climate change solutions: farming carbon through improving the quality of our soil and planting trees and woody shrubs, reducing our water usage to decrease the carbon footprint of producing clean water, growing our own food, using a number of kind of conservative plant care practices to avoid using more fossil fuels when we take care of our gardens, and then managing our plant waste and our food waste. And the last thing that I want to say is that climate smart gardening is actually practically synonymous with earth-friendly best practices. And we all want to try to adopt as many earth-friendly practices as we can in our gardens in order to protect natural resources, boost biodiversity, while we minimize waste and pollutants. And one of the key tenets of earth-friendly gardening is to nurture the soil, to build the soil, maintain the soil with organic matter, and protect the complex living ecosystem that's in the soil. And so we talked about that as a key climate smart mitigation strategy. We talked about the threats to biodiversity that climate change is posing. And in the next part of this talk, that's in 2 weeks on April 1st, we're going to be talking a little bit more about plant selection in order to protect and extend the unique plant communities that we have here in Marin. Then certainly this whole talk has been about mitigating climate change, which is a key tenet of earth-friendly gardening. And finally, creating habitat with our gardens in order to provide places where wildlife can live, and to protect our environment by avoiding the use of synthetic fertilizers and pesticides. So I just gave a plug for Climate Smart Gardening Part 2, which is going to focus on adaptation. That is the practices that we want to adopt in order to have a successful garden in face of the conditions we know are coming and are here with climate change. So that's at the same time on Thursday, April 1st. And I want to thank again the San Anselmo Library and Siriana for hosting us today. These are some references and local resources, and I understand that Siriana is gonna be sending those out to you to everybody who registered for the talk, along with the information on this slide, which tells you how to get in touch with Master Gardeners. On our website, at our help desk, we have a free newsletter, and we have a program that where Master Gardeners visit your home and look particularly at water, how to garden more water wisely in your landscape. So I understand Siriana is going to send these 2 slides out so that you'll know how to get in touch and you can explore some of these references. And with that, I think I'm going to open it up to questions. And Siriana, shall I stop my slide sharing, or are you going to stop my slide sharing?
Yeah, I'll stop your sharing. So if people have questions, they can raise their hand on their screen or using the raising hand function in Zoom, or type it into the chat box and we can get some questions going that way. Well, let me figure out my technology bit. Okay, there we go. All right. So does anyone have any questions? Again, if you have your screen on, you can raise your hand physically, or you can use the raise hand function in Zoom, or you can type it into the chat box.
I see that Elsa has a raised hand. Do you want to unmute yourself, Elsa?
Oh, let me get, oh, Elsa? I don't see Elsa's hand raised.
You don't?
Mhm.
Oh, that's my cursor. Sorry, it wasn't Elsa after all. It was my cursor sitting on top of Elsa's name. Anything you all wanted to know just a little bit more about? It's a lot of material and I went through it pretty fast.
There's a question in the chat. Any tips to compost in a way that releases less carbon?
Well, the most effective, the best way is to have a compost pile that is aerated. And so I know I'm not very good about this because I tend to pile stuff on and I don't get out there very often with a pitchfork to turn my compost pile, but a well aerated compost pile is going to be decomposing under conditions that produce less greenhouse emissions back to the atmosphere. Barbara, do you have anything to add on that?
Oh, Barbara, you're muted.
I just thought it. Yeah,
Okay.
aeration is really good. Heat. If your compost is not hot, then it would be even more important to keep it aerated. If you're unable to do that, then I would suggest really using the green bin. What do you think, Kathy?
Yeah, it's good to turn the compost pile. The larger your compost pile is, the more it's going to be likely to get hot. I think the guideline is for it to be at least 3 feet by 3 feet by 3 feet in order to generate heat inside of it. And then the other strategy, of course, is to have a somewhat even mix of brown material and green material. And by browns, we mean like straw or newspapers or dead stuff. And by greens, we mean fresh food waste and fresh plant waste. So if you have an approximately, it doesn't have to be exactly 50-50, but if you have an approximately even mix of green and brown and you have a large pile, your compost pile is more likely to get hot. And then if you turn it, it's more likely to be decomposing under ideal conditions. We have more at our website. Under basics, I believe, there's a whole couple of pages on composting. So thanks for that question.
There's another question about composting. What about in situ composting where you bury your food waste? Is that contradictory for no-till gardening?
No, actually, Barbara and I were just talking about this the other day. If you say, take the contents of your compost bucket and you dig a pretty deep hole, like a foot down. You don't want it near the soil because you don't want rats and, gophers and raccoons and stuff digging it up, but bury it pretty deeply, cover it then with soil and let it decompose in situ, as you said. That will produce wonderfully rich soil in the area where that food is decomposing. Ideally, you want to do that not exactly at the same time when you're planting something new. You're going to want to do that maybe, like, say you want to plant your tomatoes in the middle to the end of April when the weather is warmer and more suitable for tomatoes. So you could go do that now in the places where you're going to plant your tomatoes. Dig down at least a foot, dump that stuff in there, cover it with good soil and let it decompose. And, a month and a half from now, it's going to be really nice for tomatoes. So that's a great approach. Any other questions?
I don't see any. But let's see if we get any more. I'll just chat for a little bit. I want to thank everybody for coming today, and a big thank you to Kathy and Barbara for being with us today and sharing about this topic, their knowledge and their experience with it. It's such an important topic, so I'm so happy you guys were here to do this. And as Kathy said, we will be having part 2 of Climate Smart Gardening on Thursday, April 1st at 1 p.m. and on Zoom. If you've registered for this one, you're automatically registered for that one. I'm not doing 2 separate ones because it was a 2-parter. So you've already registered. Later today, I'm hoping I get it ready for you guys, for everybody today. I will send out the recording to this presentation, as well as information from those last 2 slides. And Barbara sent some links into to the chat, and I'm going to include that as well. So hopefully that'll help you guys with your new climate smart gardening practices. And it looks like we do have a new question in the chat from Kathleen. Regarding plant selection for a changing climate, what are your thoughts on native versus non-native?
Oh, good question. And we'll talk about this more on April 1st. But the short answer is that all Mediterranean plants, that is summer dry, winter, plants adapted to summer dry, winter wet weather, are going to be appropriate for our climate and for our changing climate. But the extra bonus that California natives have is that our insect communities and our bird communities and our other wildlife communities have evolved in partnership with California native plants. And so the California natives are particularly strong habitat to help make our ecosystems more resilient in a changing climate. So we are not dogmatic about, everything you plant should be California natives, but if you can help increase the proportion of California natives in your home garden landscape, you will help create habitat for our native insect, mammal, and bird communities. And that's really important because climate change is degrading the habitat outside of home gardens for our native species. So adding native plants to your garden is a habitat win, a real win for biodiversity. Thanks for that question. Barbara.
I want to say something about climate zones. The USDA climate zone map is really about chill hours, about hardiness. It's about, will your plant die in the winter? So when you think about how that might change in our county, what it means is that the cold temperatures will be getting warmer. The overall climate is changing and getting warmer. So you think that probably the temperature on the coast, which is not as cold in the winter, will be moving inland in terms of that low winter temperature. But overall, the high temperatures are getting warmer. So when you think about the high temperatures, those temperatures will sort of be moving from the other direction. If you go to those tools that I put in the chat, you can actually look at the whole county and see how the temperature changes are affecting different areas of the county. And you can see as the low temperatures sort of moving from the coast and from southern Marin inland and north. And then if you look at high temperatures, you can see that the high temperatures are sort of moving in the other direction. It's fascinating, actually.
Yeah, and then as a kind of add-on to that, we have so many microclimates in our county because of our proximity to the bay and the ocean, and also the number of hills in Marin. And so climate really changes in very local ways in Marin, and it's really important to kind of know your microclimate in order to then think, okay, how is this going to change in the face of climate change? All right.
We've gotten a lot of thank yous in the chat. Many thank yous for this presentation. So again, thank you both so much. And if there's no other questions, I think we're gonna maybe end for the day and see everybody